Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Matthew Hasty, Senior Global Product Manager at FLIR. We talk about the recent launch of the FLIR Mix starter kits, specifically the challenges that researchers face when using separate thermal and visible imaging systems, and how FLIR Mix solves them, as well as some of the typical use cases and applications the starter kits are geared towards. I hope you enjoy this episode. Let's get started. Hello everyone, and welcome back to Electronic Specifier Insights. I'm pleased today to be joined by Matthew Hasty, who is the Senior Global Product Manager at FLIR. So thank you very much for joining us today, Matthew. How are you?
I'm doing great. How are you doing, Paige?
Yeah, very well, thank you. It's a pleasure to have you here on this episode. So why don't you tell us a little bit about yourself and your background to get started?
Yeah, I'd be happy to. Thanks so much again for having me on such an incredible podcast and really representing our FLIR team. Appreciate the opportunity to discuss new technology in the electronic space. So I've been at FLIR for over 6 years, and I oversee the strategy and execution of some of the world's highest performance commercially available infrared camera systems. So this includes fixed mount cooled cameras, which are made at our Niceville, Florida facility, and then also fixed mount uncooled systems, also called microbolometers, that are typically designed and produced at our facility in Stockholm, Sweden, actually. And I lead the strategy also for our desktop software research studio, which is used quite often in electronics design and testing, and then the supporting SDKs for those product lines. So our team, we're dedicated to releasing scientific imaging solutions, really, that enable groundbreaking research and development worldwide. We're passionate about understanding customer needs, and that drives innovations like we're going to talk about today. And then just for me personally, I have a bachelor's degree in industrial and systems engineering and a master's degree in international business, both from the University of Florida. So go Gators.
Fantastic. And can you give us a bit of an overview of the company as well?
Yeah, FLIR Systems has actually been a part of Teledyne Technologies since 2021. And FLIR is really the world leader in infrared technology, so technology that can sense heat. And at Teledyne, we like to use the phrase all wavelengths from deep sea to deep space. And it's so true, as our various companies across Teledyne cover all wavelengths across the electromagnetic spectrum with solutions in deep sea to actually out to deep space and really everything in between. So it's great to be part of such a strong technology family within Teledyne. But for FLIR specifically, we've been the first with so many different technological innovations around infrared technology for decades. And it was originally founded to pioneer forward-looking infrared technology. So it's in the name, FLIR, FLIR. Our name is actually some of the original technology, which is pretty cool. But the company rapidly expanded into defense, which is what a lot of people know for infrared. But infrared's also used in industrial and commercial markets. And it's really revolutionized the way that professionals, that researchers see the world around them. At one point, the phrase was actually coined infrared as the sixth sense. So because it's something that you can't see, but it's a world that's around us that can tell you so much about what's going on. And so as more and more applications were realized, infrared has really taken off in, the past decade or so. Some examples of that could be military night vision to enabling predictive maintenance in factories and power lines, maybe empowering first responders and life-saving missions. There's even infrared cameras sold on Amazon that connects to your phone called the FLIR One. And so there's a wide range of what infrared cameras can do. I typically work with the higher end, empowering groundbreaking research and development with our cameras. So we have industry-leading sensitivity, reliability, uniformity across the images. And so really, FLIR makes more infrared cameras and sensors than anyone in the world. And we leverage that to make our customers successful each day. And so the FLIR cameras we're going to talk about today, they're fixed mount cameras, and they're used a lot in research and development and in quality assurance applications, which both are super important in electronics design and testing. We see these cameras used also in university research, commercial research at large companies, and they're just really incredible tools. It expands the world that a researcher can see. In the past, researchers, especially in electronics design, had a single pixel temperature detector. So they had one point of measurement, and that was all they could see. And now there's an entire image. So millions of data points about the temperature distribution. And a live view of it as it happens across the test. And so really, it's expanded reality for a lot of designs and quality assurance. And then also, it's allowed the ability to see down to the micron level. With microscope lenses, with infrared cameras, electronics components are getting smaller and smaller. And as those components get smaller, the requirements on infrared or different solutions to image or to get data about heat distribution gets more paramount. And with microscope lenses, you can get down to the micron level when seeing the components heat and distribution. And so our team, we leverage the size of FLIR and Teledyne, all the different technologies to integrate optics, detectors, camera design software. And that really lets us tailor our systems, our product designs to specific applications, which let researchers go further faster. And so that's a quick summary of FLIR, who we are, and then also just of my group in FLIR and what we do.
Brilliant. A great introduction. And you touched on some very interesting points there, which I think we're going to deep dive into in this episode. Yeah. But let's focus on the FLIR Mix and the FLIR Mix starter kit. So can you briefly explain for us what the FLIR Mix is and what prompted the development of this new imaging solution?
Yeah, FLIR Mix is really exciting for us. We released it earlier this year, and Mix actually stands for multispectral imaging experience. And the idea is that it's not just infrared anymore, that we're enabling researchers to have solutions that span infrared, visible, and maybe more in the future. And the way the researcher experiences that is up to them because they know what they're doing and how they need to view the data, whether it's visible, infrared, fusing it in different ways. And so that's the experience side. And some background on it, for decades, research and engineers have faced really a pretty frustrating dilemma. They've had to choose between visible light or thermal imaging during testing. And especially with high-end cameras, they've had to do this. And each brings unique value. Visible light captures structural detail, context. It's what our eyes are used to seeing. But thermal imaging reveals heat signatures, dynamic thermal patterns. And using both simultaneously, that's kind of where things have fallen apart, especially with really high-end research-style cameras that require a lot more integration to be able to do this. And so FLIR Mix, once again, multispectral imaging experience, it's really a transformative leap for researchers, making the ability to combine high-fidelity visual data and high-fidelity infrared data kind of a commercial off-the-shelf solution. In the past, this was really difficult to do, and some research labs did this on their own. They had developers and engineering costs and all of this to make it happen. But this is the first time that at a high level with high-end systems that it's become accessible to people much easier, especially to researchers. And so this gives the user a single synchronized data set, and it eliminates that trade-off between looking for heat signatures or looking for structural details in the visible. And we integrate dual sensor technology and put it all into one seamless package for the user. And the result then is a streamlined real-time solution that removes that burden of manual alignment, whether it's spatial or time. It removes the burden of post-processing. And then it assures that every frame captured reflects precise thermal nuances or data, and then also the vivid, visible context. So that precise spatial and time alignment makes it effortless for the researcher. They can buy our hardware, they can buy our software research studio and pair it together. And all of a sudden, instead of having one data set visible, one data set thermal, they have it together and they can choose how they want to visualize that data. So it's pretty exciting for us, and we think it opens doors for lots of different types of research in the future.
Brilliant. And I've got written down here that the Mix starter kits can capture imagery at up to 1,004 frames per second. So why is this level of speed and synchronization important in practical terms?
Yeah, so for electronics design and testing, high speed is not incredibly important depending on the specific test or application, right? Sometimes it might be, but in a lot of cases, the high speed might be for more dynamic testing like airbag. It could be for non-destructive testing like batteries and things like that. The higher speed gets you more sensitivity. But as you get higher speeds, there's lots of data there, right? And so at the heart of FLIR Mix is something really unique to FLIR, and it's our integrated imaging architecture, which lets us record events up to 1,004 frames per second on both cameras without losing frames. When you're in a high-speed test like that, they're typically expensive, right? And you don't want to have to do it again. And the most critical frame where defect occurred or where some type of anomaly occurred, we don't want that to be the frame that we dropped. And so that's why this is so important, being able to capture high frame rate to give you fidelity into the event, but also not to drop the frames when it happens. And then the other important part with that too is that, say you're looking at frame 500 in visible and infrared, you want to know that that frame is the same frame in both. So that if you're panning between both, you don't want to look at something in the infrared and have it be an inaccurate time synchronization to the visible imagery. And so that's what makes these, what we call starter kits, so important, because we provide all of the hardware specified by FLIR to really help the user get started putting the cameras together. A lot of this is leveraged in our software, which means that the users can combine really whatever cameras that we support together. But the starter kits really gives the user a good starting point to ensure that they're going to get the best results possible.
So can you tell us a bit more about some of the applications or use cases that the starter kits are geared towards?
Yeah, the starter kits, they're really designed, like I was saying, to be as plug and play as possible. And so we meticulously designed them to address a broad spectrum of different advanced applications that we know people use our cameras for. So there's a lot of differentiated kit configurations that we have. And one of them is the X series starter kit. That's what we were talking about with the high speed, 1,000 frames per second, right? And it's tailored for really high end, high speed research environments. And it combines our FLIR X6980 HS thermal cameras with the high-speed visible cameras, also precision optics, custom mounting hardware, along with the recording hardware. And so it supports really demanding applications. The other is the A-Series starter kit. And that's a more versatile solution, a little bit lower cost for sectors like electronics design, renewable energy, battery testing, university research. And with that kit, we integrate our A6700 platform of thermal cameras, which ensures capture robust thermal data, but also fine visual detail. And then for researchers seeking post-processing flexibility, but maybe they're not looking to buy the visible camera hardware today. Maybe they already have an infrared camera and they're going to wait on buying the starter kit. They can also just buy the FLIR Mix toolkit. And that's a add-on license to Research Studio, which gives the user the ability to do mixing with supported cameras in Research Studio. This toolkit license comes with the starter kits typically, but if the user just wanted the software solution, they could also buy the toolkit license. And then that gives them the option to seamlessly synchronize thermal and visual footage in real time, or to combine two files after the fact and synchronize them together. And so say you already have visual data and you already have infrared data, we'll actually let you pull them together in software after the acquisition, which gives you some more flexibility, maybe on the hardware you use in terms of the visual camera and the setup.
Fantastic. Can we deep dive into one of the applications you mentioned, which was electronics design or battery testing? So how exactly does the A-Series kit help engineers capture thermal anomalies in real time?
Yeah. So the A-Series kit definitely helps with that because those cameras are what we see used mostly in electronics design and testing. Some of that's the price point, but some of that's the design of the cameras with microscope stands and the size and form factor, and also our microscopic lenses that are offered with them. But one of the challenges when you have electronics design and testing is the size of the components and using microscope lenses. And aligning a visual camera to an infrared camera at the microscopic level can actually be quite difficult. And so a really exciting aspect of the release of FLIR Mix is actually what we call static mix. This is actually available to all Research Studio users. So anyone that already has Research Studio, if they have the most up-to-date version of the software, they can actually use static mix. And what this is typically the visual spectrum in electronics design and testing is not changing significantly. So if you're looking at a printed circuit board in the visible spectrum, that's not changing a lot. So if you had a static image, whether it's a picture from an iPhone or a board schematic or layout or something like that, and then the ability to overlay it onto the live infrared image from the A-Series camera, that's extremely powerful. And see, the infrared and the heat is the most interesting point of data to improve designs, to identify defects, right? But the visual spectrum lets the researcher understand structures, identify components, have a perspective of the layout of the board. And in general, the human eye prefers to look at visible imagery because it's what we're used to. And so with static mix, when you overlay a visible image onto a live microscopic infrared feed, then you can actually look at the visible image and see temperature per pixel. So you actually have infrared data behind it, but you can look at an invisible image and see the temperature. And then what a lot of people will do is they'll do what we call fusion, but essentially it's a threshold. And you can set a threshold so that when the temperature goes over a certain point, it starts to colorize that. So imagine looking at a visible picture of a printed circuit board or a visible layout, and then as a certain component gets above a certain temperature, it starts to colorize. And then you know that's where you need to focus and look. And then, of course, you can do all kinds of data analysis with plotting, statistics, different mathematical functions, and things like that, because you have actual infrared data behind that visible image. And so we're really excited about this. This is powerful. One of the things with infrared in the past has been, yes, I'm watching my test in the infrared of this electronics board, and I can see where the defect is. But when you're so zoomed in at a microscopic level, or you're trying to look at different parts of the board, it's very hard to know what component that is. And you can't always read the label, especially in midways infrared, which is most common for temperature measurement where we're at with these high-end cameras. And so now you can actually see the label on the different components. And now you can actually identify where you are in the layout of the board. And so we're excited about how this is going to enable research globally. And the beauty of it being included in the standard Research Studio software set is that anyone who already has the software, anyone that already has a camera, we can really help them take their research further faster.
Excellent. Yeah, that was going to be my next question. How seamless is it to upgrade or integrate the Mix ecosystem for teams that are already using FLIR cameras?
Yeah, so the static mixing is really easy. If they have the most up-to-date version of the software, they can just start using it, plug in their camera, and then you just go select an image, PNG or JPEG, to overlay, and then do a spatial alignment to get it on there. For the rest of it, if you're interested in buying hardware too, the mixed starter kits, they're designed to be seamless. They're designed to be plug and play and make it as easy as we can. We're talking very high-end research. We're talking high-end tools, right? And one of our goals is we want to have the highest performance and most flexible systems possible, but we also want to make them easy to use, almost like a consumer product, right? And so the mixed starter kits, they're designed to work with existing research and development cameras already in the field. And so they add a whole new dimension to your data captures. We talked about the A series and the X series kits, right? So if you already have an A series camera or an X series infrared camera, you can buy the starter kit and get everything you need to all of a sudden turn your system into an infrared plus visible system. To be clear, the kits are purchased in addition to the infrared camera. So if you already have an infrared camera, you purchase the kit and then you get the extra accessories to be able to do mixing. But if you wanted to get both, you would buy the infrared camera plus the mix kit. In addition, we don't limit researchers in our software really ever. We try and keep it as flexible as possible in Research Studio. So any supported camera, infrared camera in Research Studio can actually be mixed with any supported visual camera in Research Studio. The results might vary if the user chooses a very high-speed camera with a slow camera or different resolutions and fields of view. But we don't always understand the research application. They vary all around the world. And so we want our software to let the researcher have the handles to do whatever they need to do. And so kind of in summary, the integration is very simple if the user or researcher decides to use a starter kit and kind of stay within our bounds, but also we open it up to make it as advanced and complicated too as the user needs, because sometimes research is not as simple as a starter kit.
So can users export the merged data sets into third-party software, or is all the analysis confined to Research Studio?
Most definitely. I mean, Research Studio has some great analysis functionality, like I mentioned before, with statistics, plotting, mathematical functions, things like that. But we know that ultimately we're limited in what we can do in that area. And there's some companies and even developers within research groups that have the exact tool that they need or the exact data processing, right? So one of our core values in our research and development team, market segment team at FLIR, is that the researcher data belongs to them. And so we want to have the best software possible to control the camera, to get the best fidelity data, to record the data, all of those type of things. But once the data is recorded, we make it as flexible as possible to get to outside applications for deeper analysis. We have a file SDK, which offers export to outside programs like MATLAB for analysis, or really any program or nature that the developer's looking for. You can develop in Python with it. It's very, very, very flexible, multi-operating system, etc. And typically the export from a data perspective would be done probably on the infrared data. And then I just wanted to mention this too. Beyond the data export side, Research Studio is actually designed to make collaborating with global teams and sharing with management teams at the end of the development project or test, or even for toll gates during, right? It's designed to make that seamless. So we offer a free tool called the Research Studio Player, and that offers actually full analysis capability if exported from a licensed Research Studio instance. So take a university research team with 4 or 5 students. They pay for one Research Studio license, and that's how they control their camera. That's how they record their data. But if they export using that actually paid for license, they can go send it to this free Research Studio player and get free, almost full analysis capability. So it enables, within one kind of license context, a lot larger team to be able to do analysis together. And then finally, we offer lots of various export options, from still image formats, video formats, that enables easy visual sharing with management whenever those toll gates are trying to get, the data or the pretty imagery or pretty video out of the software. And then finally, just in terms of global teams, we know that teams are not confined to one location, to one country, to one language anymore. We're really a global world now, right? And so Research Studio is multi-platform. It works in Mac, Windows, and Linux. And yes, a researcher could record on Mac, and then the guy or girl doing the analysis later could do it on Windows. The files cross between platforms. And we also run in 21 different languages. And so it's seamless to switch between languages, so the researcher can work in their language of preference also. And so we've really worked hard to make Research Studio from the ground up a global tool, and then also to enable larger development teams to easily collaborate together.
Excellent. Thank you for that. I know our listeners will appreciate you deep diving into those features. Given everything that you've said so far, and with multispectral imaging becoming more important across a variety of sectors, I'm interested to hear where you see the greatest demand coming from today.
Yeah, I mean, by converging high-speed thermal captures and with high-resolution visible imaging, FLIR not only provides a complete picture of fast-moving thermal phenomena, right, but it also elevates the quality and the reliability of multispectral data for researchers. So it's really a breakthrough technology. And so it empowers scientists, engineers, innovators to interrogate and understand intricate thermal environments with really unheard of before clarity and speed to do that with a really nice desktop software. These data sets are comprehensive. They're real-time merged data sets, and they give the researcher really a more nuanced understanding of dynamic processes. And then that drives breakthroughs in fields as diverse as defense, material science, renewable energy research, electronics design and testing, battery design, battery quality testing, battery destructive testing, lots of different areas. And so for us, it's a paradigm shift. And I think for the market too, in infrared and then multispectral imaging technology. And it accelerates discovery because research teams really should focus on the research they're doing, not developing a tool to pull together the data or developing a tool to actually use the instruments that they have. And so we really believe it's going to accelerate developments because it simplifies data integration, it enhances analytical precision, and it lets the researcher actually focus on their own scientific inquiries and their own innovations rather than on time-consuming post-capture, data reconciliation, image alignments, all those different things. And so we're really excited just of how this software is going to partner with commercial companies, industry, universities, researchers to really help drive breakthroughs in many different market areas, but ultimately in research, right? And electronics design is a huge one of those.
So for those interested in evaluating the FLIR mix, then what's the best way for them to get started or to see a demo in action?
Yeah, one of the beauties of FLIR and one of the beauties of Teledyne with our reach and how large we are in a global company is that we have a robust direct sales and partner network everywhere in the world with in-stock demo gear. I tell researchers quite a bit that the infrared systems that the research team sells, my team, are quite expensive. They're expensive purchases, right? And if I was in the shoes of a university student or a PhD researcher or someone leading a team at a large company, I would want to see the instrument in my test before I put my name on that large purchase. And we really believe in that here at FLIR, and that's why we have demo gear around the world. We want to show you the camera. We want to have an expert sit there with you, show you how to use it, make sure it works for you, help scope the proper optics, filters, calibrations, everything. We're really here to partner with you. And so our team would be happy to scope your application and directly demo any software or tools. I think the best way to reach out to us is via our website or just my email and contact info will be provided with the podcast afterwards. And then you can feel free to find me or some of our team members on LinkedIn. And then I can direct you to the best person, whether it's a direct salesperson or a partner locally for you.
Fantastic. Yeah, I'll put a link to the website and to your details at the end of this podcast so our listeners can easily access that. Okay, before we wrap up then, Matthew, is there anything else that you want to add?
Yeah, I guess I just wanted to say thank you so much for having me on this podcast and having FLIR a part of it. I think this is our first time on here, and so it's a great opportunity. And we're excited because we feel like we've solved a big challenge for researchers. And, we're honest that this technology has been available before, but it's been available to larger companies or teams that invested significant resources to do the data processing. And so we've really made a technology breakthrough available to many more people. And I think in a lot of ways to university students, PhDs, researchers that maybe have to look for tools that are already developed sometimes because they're trying to focus on their own research. And so I'd love to talk with you about this tool. I'd love to talk with you about how this could be used in your applications. We're always looking to get better. We know that this is something we're continuing to pursue. So we're continuing to add software features, look at different hardware ideas and things like that. And the only way we do that is by being close to customers and researchers. And so I travel a lot. I travel the world because I like being face to face with people that are actually using the products and are seeing breakthroughs in research and development with them. And so, yeah, please reach out. I'm always interested in hearing about technology and specifically how our technology is helping you.
Excellent. Well, thank you for your insights, Matthew. I know our listeners can probably hear the passion and that you have for the technology. So it's been a pleasure hosting you. Thank you very much and enjoy the rest of your day.
Thank you so much.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.